So, this is an introduction to forecasting, and forecasting is the third and final component of our Stats 2 class. And it's been my experience that this is the component of class that students enjoy the most, that for a lot of students makes the most sense. And my hope is the same for you, that even as we go to this modified environment that's online, that you'll be able to grasp forecasting fairly easily. And I think it's something that even in an entry level position, anybody can see themselves doing. So I really want us to focus on this part of the class, even though currently there's really only one event that has any of our focus, and it's this ongoing COVID-19 pandemic. And so I just want to be mindful of all of you that are graduating. I am sorry that you won't be able to walk for this year's commencement. My hope is that they'll figure out something where you can walk later on. But congratulations to you nonetheless. I know it's a big deal, and I know there's a lot going on to you, so I don't want to be dismissive of any of that. And I think actually the current times really stress the importance of forecasting. So all of a sudden people are really, really interested in what will happen tomorrow, what will happen next week, what will happen 6 weeks from now. And so the importance of getting forecasts correct is essential. And if you think of just this current pandemic, forecasting the number of new cases of COVID 19 is important on any practical level. So, right now, I'm living in Birmingham. We have a shelter in place order. And the reason why is because we are forecasting a number of new cases that hospitals will not be able to manage. And so our policymakers have taken whatever data that they have that are available based on the tests in other states, and they're making decisions based on forecasts of future events. Local businesses also have great interest in this data. So if you run a small business, you're interested in when you might plausibly reopen. So you know that you're limited in who can visit your business now. There may be shelters in place where you are, or there may just be a general lack of demand due to social distancing. And you may be able to hold out for a month, but it'd be a lot harder for you to hold out for 2 or 3 months. And it may make sense just to shut down now, let your employees start filing for unemployment rather than furloughing them and eventually firing them. So that's a stress for businesses. If you're an investor, my parents are in their 70s and they have to think about, should they stay in the market? Should they leave and come back? The Dow is in the 21,000 range right now. Will it go to 18? Will it hang around this range? Will this $1 trillion stimulus work? There's a lot of uncertainty, and the underlying data series that we're trying to forecast is the number of new cases of this COVID-19 virus. And I point out four sets of constituents. Obviously, there are many, many other constituents that have interest in this. The whole world is interested in this. And so even as we think about this pandemic right now, the notion of flattening the curve, quote unquote, is predicated on there being some type of data generating process, some pattern to the new cases. So based on how people interact with each other, we believe that due to the amount of ease with which the virus can be transmitted to other people, that relationship drives the number of new cases, and that can be predicted. And so forecasting is a way of tracing out that curve, and over the next few weeks we'll mess around with some of the data that we're seeing right now and see if we can do some forecasts ourselves. But for this class, we're not trying necessarily to forecast something that's in a biostats class or that would relate to epidemiology. We're forecasting for business, and forecasting is absolutely essential to businesses and many other organizations. So if you think about Georgia Power, they have an entire team devoted to day-to-day forecasts of energy usage. And all the team is trying to do is predict energy usage from the customers, because huge spikes in demand are going to be expected by the customers to be accommodated by Georgia Power. If Georgia Power doesn't accommodate those customers, the customers are going to be pissed off. I don't have any power. The electricity is out. That's a dangerous situation for the customer, and it's also bad for Georgia Power. They may have to buy power on surge demand from other providers across the country. Think of a multinational firm. They must forecast demand in every country that they operate in. So I may have a forecasting team in the US, but I'm also selling goods in Australia. So right now in Australia, we've just exited summer. We're heading toward fall. That is different from the US where we're entering spring and summer. So if I run an apparel company, for example, like Nike or Under Armour or any company that plausibly sells goods around the world, I need to have a team that is forecasting idiosyncratic demand patterns for each of the countries that I sell in. So I'm not going to try to offer the same apparel at the same time to different places across the world. If you think of going into a profession as a teacher, you obtain a defined benefit plan. This is called the Teachers Retirement System of Georgia. And they are projecting returns for the future, and they adjust the assets that they hold today based on their projections. So states have lots of incentive to be as accurate as possible with how they project their rates of return to be on the assets that they hold. So these states hold billions of dollars in assets, but they have to give those assets to teachers when they retire. That is the point of a pension plan. And if you get it wrong, if you are lower on your pension obligations, you can't pay teachers as much as you promised them when they retire, and that's thought to generally be a bad thing. So, if you look at the state of Illinois, they're far behind on their pension obligations, and this is a real source of concern going forward. Take a look at Krispy Kreme. Now, all of us are thinking right now, hey, I would love to go out to Krispy Kreme, grab a nice hot donut. That would be delightful. I agree completely, and hopefully we'll be able to do so very soon. But there are three main drivers of business. You've got these new stores, you've got new off-premises customers like Racetrack, QT, the Piggly Wiggly, etc., and you've got these seasonal factors. And so if you open a new store, Krispy Kreme will forecast your sales from the opening week through 18 months out. So if I choose to start a Krispy Kreme franchise in Carrollton, Krispy Kreme will project my demand for me. They're very accurate. They communicate their meetings with managers monthly to illustrate these forecasts. And the forecast is roughly 1%. But it's critical. If I'm a franchisee of any large restaurant chain, I want to know exactly what to expect with respect to my demand. That is what generates the revenue and generates the profit for my franchise. Conversely, if I'm Krispy Kreme, I have no interest in seeing the Krispy Kreme in Carrollton fail. None at all, because consumers will remember that, hey, this business failed. And it's bad for the brand name if you have to close 50, 75, 100 stores. So forecasting is an essential component to operating a business. Many students, when they graduate from this university, part of their entry-level responsibilities will be to forecast some sales. I've got some previous sales data. Can you communicate what I should expect going forward? And you'll be expected to do this. They want a number. Think about forecasting within the context of supply chain management. You have suppliers of raw materials who are supplying those raw materials to producers. Producers produce finished goods that they then sell to distributors, i.e. retailers, wholesalers, etc., who sell these goods to customers. So the supplier of the raw material does not actually have data on the customers. Distributors must communicate that data up to producers quickly, and those producers must communicate with the suppliers. So if you think of the supply chain, if there is miscommunication or a mismatch in expectations about future purchases, that's very costly to everyone. So you may lose customers due to stockouts, where the stock of the product is out. If you think of shopping online for clothing, all of us have been online shopping for clothing. We see something that we want to buy. and we look to see if it's in our size, and it is not available online. Now, what I don't do when I see this is say, hey, well, let's give these guys 2 weeks to get it together. I'm going to bookmark this website. I'm going to check back periodically to see if they have this product in stock. I do not do this at all. I just go to the next company. All right, and many customers are the same as me. We're very impatient. We do not want to wait around for some product that we only like a little bit better than the next product. We just want to buy something. If I'm in the mood to buy, for example, a pair of shoes, I want a pair of shoes. I'm open to getting the exact type that I want, but really I want a pair of shoes first and foremost. So the stock out is very costly. If I don't project demand correctly, then I may have to order products very quickly, rush delivery. If you think of sending anything next day air with FedEx, that's very costly. You're going to have better timing for sales. So look, I mean, we're in the middle of the COVID-19 pandemic. It behooves a number of retailers to try to think about offering sales now of selected products that people may use to try to get people to buy these things. If you think of holding inventory, it's very costly. You have to operate a warehouse. If you think of excess capacity, it's very costly. You have unused machinery. You can lower your inventory and capacity buffers if you have accurate forecasting. So accurate forecasting of customers, of costs, of sales, of revenue, all of these things are essential to business. You know, just to give you another example, if you watch any show on HGTV where they're renovating some property to try to sell it later on for a high price, there are forecast errors with respect to how much it will cost to renovate the property fairly regularly. And as a consequence, sometimes these projects don't make money. So businesses often have to make decisions based on the future, but we don't know what the future holds. And I think that's never been more evident than today. We do not know what the future holds. So even think of speculating on the stock market. Consider how much money you could make from knowing the duration of the COVID-19 virus. You know, if I knew it would last 2 months versus 18 months as far as having damaging effects on the economy, I could really take a position to leverage that knowledge. But I don't. I don't know what the future will hold. I think I may have some idea. You think you may have some idea, and we don't necessarily know. So despite not knowing, it is still worthwhile to try to make as accurate of a prediction as we can. So I still want to try to learn about the future, even if I don't know what it will hold precisely. And how we, quote, learn is via a forecast. Now, to define what a forecast is a quantitative prediction about the value of a random variable at some point in the future. So a forecast is a number. It's a number. And it's a random variable because we do not know what the future holds. And so just to give you an idea about what forecasting is, we are just going to deal with one quantitative variable, y. And it's the variable of interest. We've observed it in the past. All the data that I have is the data from today and in the past. So I observed today. Let's call it YT, T for today. I observed the previous period. Now it could be a quarter, i.e. GDP. It could be months, like unemployment. It could be yesterday's sales. The duration of T is irrelevant, but I want to define T as a point in time. So T is today, T minus 1 is the previous period, T minus 2 is 2 previous periods. The period could be a quarter, it could be a month, it could be a week, it could be a day. That's not as relevant. Well, I don't want to say it's not relevant. I just want to say that I index time in the same way regardless of the duration of the period. Let's put it like that. Now, I could also potentially have some information about other variables that were observed in the past, i.e. a whole vector of x variables. In this class, we're actually not going to deal with those types of forecasts, so they may be relevant. We're just going to try to use y to forecast y. So we're not going to take in any other information that may be helpful in trying to predict y tomorrow for the simplicity of this is a very basic forecasting class. So to circle back, we're just using data on one variable to forecast future values of that same variable, and we call the future t plus 1. So I use information from today, that's time t, yesterday, that's time t minus 1, two periods ago. That's time t minus 2 to predict t plus 1. And just to give you a timeline of this, think of starting at time period t minus 2. That is to the left of the timeline. Now, if you look above, yt minus 2 is what we observe at time period t minus 2. So I am recording these slides on a Sunday. 2 days ago, it was Friday. I observed the temperature on Friday. That would be yt minus 2. Based on that, I can make a prediction, a forecast, if you will, for the temperature on Saturday. That is yt minus 1 hat. Hat stands for forecast. Then Saturday occurs. That's t minus 1. I still remember what Friday's temperature was, but now I also have Saturday's temperature. So I've observed both yt minus 2, that was Friday, and yt minus 1, that's Saturday. I have the option to use both of those pieces of information to make a prediction for the temperature today, which is Sunday, the high temperature. I make a prediction, then today I observe it. Yt is observed. I've observed Sunday's temperature, Saturday's temperature, Friday's temperature. I use that information to make a prediction for tomorrow, which is Monday. Now, once I observe today's temperature, there's no need to forecast it. So I'm going to see what the high temperature is today, and then I don't need to circle back and be like, well, based on today's high temperature, the high temperature is 77. We know it's 77. All right, we do not need to forecast the 77. It already exists. What I can use the 77 for, along with Saturdays and Fridays, if I choose, is to make a prediction for tomorrow, and that's t plus 1. So think of t minus 2, t minus 1, t, and t plus 1 as all being different points in time. I observe information from the past. So I keep the information from the past. Think of it as kind of like a set of information set. I keep that information. I use it to predict t minus 1. I get some information at t minus 1. I keep the information from t minus 2, use it to predict t, etc. Now, we are assuming that there is some type of systematic process to analyzing the data. There's some systematic way that the data is produced. We don't know what the process is. If I knew what the process was, I would just use the process. So what we do instead is we try to replicate the process as best we can with some known techniques. So think of it as like, I'm not sure exactly how the recipe was made, but I have some general idea about how to cook, so I'm going to try to get as close to the recipe as I can based on knowing a little bit about how to cook. And so we can get some clues about the process by looking at how close our forecasts are to the data and how much they miss the data by. These are not the same things. So one is a measure of accuracy and the other is a measure of precision. So if I make a bunch of accurate forecasts but then I miss badly, is that somehow worse than being mildly inaccurate all the time but never missing that badly? And we don't like either one, but we're going to try to figure out which of those sets of circumstances is something that's more concerning to us from a forecasting perspective. Okay, so the very first model of forecasting is called the naive model. It's a very simple model. And the model is just that time t, that's today, is the same as yesterday. So if I'm predicting today, yt hat, let's call it hat for forecast. If I'm making a prediction for today, that's yt hat. If I think it's the same as yesterday, then yt hat is the same as the data from yesterday. It's not sophisticated. So basically how it is what was the weather yesterday? That's how I'm choosing to dress today. I do not see any difference whatsoever. So this is not actually what meteorologists do. They use something more sophisticated, but this is what we're going to start with. Epsilon. This is an epsilon. It's called a forecast error. It takes the same role as the residual from a regression. So y is the true data point. So I make a prediction for today. I observe today. What I observe may not be the same as I predicted. So y is the data, yt hat is the forecast, epsilon is the data minus the forecast. So data on the left, okay, take a look at where the cursor is, forecast on the right. This is called forecast error. It shows us how much our forecast missed by. If I want a percentage error, did the forecast miss by 1% or 10%? I can take the data minus the forecast in the top, that's the error, and divide by the data. And that's like any other percentage change. So let me give you an example of how to do the naive model. The naive model, let's just look at some Exxon Mobil stock prices before the COVID-19 pandemic and before the Russia-Saudi Arabia oil price war. Okay, and here they are from the beginning of the year, and you can take a look at these closing prices, all kind of hanging out in the 69 to 70 range. Here is January 2's data. The stock for ExxonMobil closed at 70.9. What is my forecast for January 3? 70.9. So if we think that the price represents the sum of all expected future dividends and profits, then that's my forecast for January 3. Now the actual data is 70.33, so I predicted 70.9, but it closed a little lower. I missed by 0.57. That's 70.33. That's the data. That's in column 2. Minus 70.9. That is the forecast. That's in column 3. And I get an error of 0.57. Minus 0.57. You can miss up. You can miss down. The percent error, and this should also be negative, is 0.81%. So let me show you how to make some forecasts in Excel. Let me just keep the date right here. Here's the closing price, and let's make a naive forecast. Okay, so I'm going to delete all of these other columns here. This is the data, and this is the time. Here's the forecast. I'm typing in forecast in Excel. No data for the first one. For the second one, you just type in equal and you click the previous data point. That's the forecast. So take a look. Click the previous data point. My forecast for January 3 is the data from January 2. Okay, and you just copy it. Now I'm hitting Command C with my Mac. That's Control C with a Windows PC. And I just hit Enter for all the data I've made the forecast. Now the error. You take the data that's in column B, you subtract the forecast that's in column C, and you just hit enter. You copy it all the way down. Now for the percent error, I hit error divided by the data. And copy it all the way down. And you can see here that I can actually change to a percent by formatting the cells. Okay. Easy to make these forecasts. So this is how I made this table that you see here. I just used Excel. Okay. Very easy to do.